Good morning, students. Mr. Carver here. Today we're going to start a unit on logarithms. They are not as bad as they sound, I can assure you. So today we're just going to start with the basics of logarithms, what they are, how to rewrite them in different forms, and how to evaluate them. And that's really all we're going to be looking for today. And that's what I'm going to have you do for tonight's homework. All right, so let's get started. All right, we'll start with this example. Log base 3 of 9 equals 2. And let me just write that out because this is the way you read this. Log base 3 of 9 equals 2. And when I say base 3, that 3 is actually a subscript. It's written below the line. So it's log base 3 of 9 equals 2. Okay, now that's the way you read it. What I'd like you to put in your notes is this. Logarithms, or logs for short, are exponents. Very, very important. And I'm going to refer back to that as I work through this problem. Logs are nothing more than exponents. Okay, now what we're going to do is we're going to take this log base 3 and I'm going to rewrite it in exponential form. All right? All right, so log base 3 of 2 is written in log form. And the reason it's written in log form, or the reason it's said to be written in log form, is because the word log is in it. So this log here means it's in log form. Now, what I want to do is convert it to this thing called exponential form. And here's the way we're going to do it. I'm going to work through a few examples just so you can get the hang of this. What I'm going to do is I'm going to take this base number right here, this 3, and I'm going to move it over to the other side of the equal sign. Now, when I do that, that 2 is going to become an exponent. So that becomes 3 to the second power. So I move the 3 from the left-hand side to the right-hand side, and it bumps that 2 up into the air and becomes an exponent. Now, when I do that, the log goes away, and what I'm left with then on the left-hand side is just 9. This is called exponential form. So tonight, the homework is going to have you go from logarithmic form to exponential form, or going the other way, and we'll do that in just a couple of minutes. So if I just gave you this problem right here, and I said, write it in exponential form, this would be your answer, and you would stop right there. Now, when I say that logs are exponents, this is what I'm talking about. This 2 is actually an exponent. So the log base 3 of 9 is just equal to the exponent that 3 needs to give you this big number 9 here. Okay, now, let's say I wanted to go the other way, back to log form. And again, I'll work through a few of these. We just reverse the process. What I'm going to do now is take this 3, and we already know what the answer is going to be, but I'm going to pull it out from underneath the 2. So what's going to happen is the 2 then, the exponent, falls to the ground, and as the 3 crosses over the equal sign, the log appears. And the 3 becomes the base. So you write it little and down below the line, and then the 9 stays there. So now I've gone back to log form. All right, we'll work a couple of more, just a few more examples. All right, here's an example of a statement in logarithmic form, or log form. Log base 5 of 25 is equal to 2. That's log base 5 of 25 is equal to 2. So this is log form. And then what I want to do is rewrite it in exponential form. So here's what I'm going to do. I take the 5, the base of the log, and I bring it over to the other side. Now when I do that, that 2 goes up in the air. Also when I do that, the log disappears and I'm left just with the big number. So that is exponential form, just like we did in the previous example. An exponential form because I have an exponent sitting on a base. That's exponential form. If I have a log in the problem, it's log form. All right, now let's go backwards. And we already know where we're going, but here we again. I take the base of the 5 and I move it over to the other side. I pull it out from underneath the 2. The 2 falls to the ground. And then when it crosses the equal sign, the log appears, and the base of the exponent becomes the base of the log, and your 25 just stays there. So that then is log form. All right, a couple more examples. What if I had log base 4 of 1 is equal to 0? All right, again, this is log form. And I want to go into exponential form. So I'm going to take this 4, I'm going to move it over to the other side. The 4 serves as the base. The 0 gets pushed up in the air. That becomes the exponent. And as soon as I do that, log goes away, and I'm left just with the number. And as you can see, it's a true statement. 4 to the 0 is equal to 1. So this is exponential form. And then if I wanted to go back the other way, I just reverse the process. The 4 comes over to the other side. When I pull the 4 out from underneath the 0 falls to the ground. As the 4 crosses the equal sign, it becomes the base of the log, and the 1 just stays there. Then I'm back into log form. So you can just move them back and forth on either side of the equal sign and get whatever form you like. Okay. All right, the next thing I'm going to have you do is I'm going to have you evaluate log expressions. That's a fancy way of saying that I'm going to find the exponent. So it's actually easier than it sounds. You're going to find the exponent. So log base 2 of 4 is my first example. I'm going to set that equal to something. We'll just say it's x. Set it to whatever letter you like. And then to make it a little easier to see, I'm going to switch from logarithmic to exponential. So again, what I'm going to do is I'm going to take this base and I'm going to move it over to the other side. The log disappears. The x becomes an exponent. So it's 2 to the x is equal to just the big number. Again, the log has disappeared. So now, all you have to do is find this letter right here, and you got it. 2 to which power gives you 4? X in this case is equal to 2, because 2 squared equals 4. So as soon as you found the exponent, you have your answer, and that's all you have to do. All right, what if I had something like log base 5? No, let's not do that. Let's do log base 3 of 27. And again, just like we did before, you want to set this equal to anything at all. Just let it equal some letter, and that's what you're looking for. Now I'm going to switch this into exponential, so I take 3 and I move it over to the other side. This gives me 3 to the x is equal to 27. Remember, the log disappears. The base of the log becomes the base of the exponent. And then you just have to start thinking about what you have to raise 3 to. 3 to the first is equal to 3. 3 squared is equal to 9, because that's 3 times 3. 3 cubed is equal to 3 times 3, which is 9, times 1 more 3, which is 27. And we got it, which means your x is equal to 3. Again, you're just looking for the exponent. All right, now some of these get a little tricky. How about log base 4 of 1/4? Here's what I'm going to do. I'm going to set it equal to any letter you like. We'll make that x because it happens to be my favorite. In fact, it's excellent. All right, I'm going to take the base here, 4, and I'm going to move it over to the other side. So this is going to give me 4 to the x power gives you 1/4. All right, now hang on here. I'll give you a little hint. That's 4 to the first in the bottom. And if you recall from first semester, how do you get this 4 to move from the top to the bottom? You make this negative. So in order to make it move to the bottom, I've got to let x equal -1. Because if I have 4 to the negative first, remember, that's 4 to the negative first over 1. What happens here? That negative says move it to the bottom, and I end up with a 1 on the top and 4 to the first on the bottom. That means x is -1. All right, how about this? Now, if you get a fraction, what I want you to do is start thinking about the number inside the fraction that has the same power as this base here. All right, let me show you what I mean. So again, what I'm going to do is I'm going to set this and equal it to x. Then I'm going to move it into exponential functions, so I'm going to move this over to the other side. This is going to give me then 3 to the x power is equal to 1/9. And what I'm saying now is this. What I want you to do is keep the right-hand side the same, that's 3 to the x, and think about 9. What is 9? What power of 3 is 9? Well, it's 1/3 squared. All right, now look, in order to get this 3 to move to the bottom, this has to be negative. So all I have to do is say let x equal -2, and I have it. Because if I have 3 to the -2, remember that negative right there says move it to the bottom. That gives me 1/3 squared, x is equal to -2. That is your answer. All right, here's another way of looking at it. You could do it this way too. If you have 1/9 is equal to 3 to the x, 9 is the same as 3 squared. That's equal to 3 to the x. This 3 is on the bottom. So what I want to do is move it to the top, and when I move it to the top, I get 3 to the -2 is equal to 3 to the x, and then you can see if the bases are the same, basically I just use the exponents, x is equal to -2. Whatever way works for you, I don't really mind, but you'll get there either way. All right, guys, I think that's it. Please send me a note if you have any questions. Hope to see you guys soon. Take care. And I hope you're doing well. Thanks.